problem, that is sorting of arrays. Okay, now sorting of arrays is a very important field, or I can say very important topic in the field of arrays, or even in the field of any data manipulation, where you need to sort in the increasing order or in the decreasing order all the elements of the array. Okay, in this case we will apply this on the array, but it can be applied generally to all the data structures, that you need to sort the values either in the increasing order or decreasing order. Right now we have in with you with us that there is an array with 5 elements, and these are the elements of the array. Okay, now what is required is this output, right? 1 2 4 6 9, right? And you can easily identify that this is the increasing order or increasing sorted order, right? Okay, you can also take it as a decreasing order also, where it could be analyzed as 9 6 4 to 1 in the reverse order. Okay, now it is up to you, or as per the need of the problem that you are solving, that you have to take increasing order or decreasing order. Okay, now we are taking here the problem to solve it in increasing order, right? Increasing order, we are taking it in increasing order. Okay, now for increasing order, again follow this same step, again follow the same trick that I have told to you, that elaborate the technique how your brain does this. Okay, now ask from your brain 46291, is it able to identify this output from this particular output or not? Okay, I am sure that your brain can analyze this and identify this output. If your brain can do, then a computer can also do, if you find out just the data and process. Only the two things you need to identify: what the data your brain needs and what the process it has performed. Right, now suppose we do it in the form of brain analysis, so I will just write it like here 46291. Okay, now let us scan from here. Okay, now ask from your brain that seeing this 4, okay, seeing this 4, it will look like the 4 is the biggest element, right? Or it is the smallest element. You cannot identify, right? Exactly. Okay. Now, suppose you have all the elements with you, right? So now 4 will be compared with this 6. Fine. So 4 will be compared with this 6, and if 4 is less than 6, then it should not be a problem. Okay, but if it is greater than the new number, the number, now suppose 4 is compared with 2. Now what you can see here, that 4 is greater than 2. It means 4 this 2 should come in the place of 4, and 4 should not be placed here. Okay, we don't know the exact place of 4 right now, but we know that this 4 should not be here. Instead of this 4, it should be any other number which is smaller than this number, if it is found. Okay, so I compared starting with 4 compared with 6. Okay, and I then compared 4 with 2. Okay, now 4 with 2 is compared. So what will happen? This 2 will replace, or this 2 and 4 will interchange their place with each other. Okay, now this is the step 1. Okay, now this is step 2, and this is result of step 2, right? And in the same step, now this first element has been compared with this has been compared with this. These two steps we have performed. Now in the third step, this will be compared with this. Now this is the third step. Okay, now 2 is compared with 9. Obviously 2 is less than 9, so 2 should be it's on the right place, and 9 is also in the right place. Okay, it looks like that. Okay, but we will see further, right? So this comparison does not make any difference. Now this 2 is compared with 1. Okay, now as soon as this fourth comparison takes place, so what will happen? You find that 1 is smaller than 2. It means 1 and 2 are not at their right places. So they need to exchange their places. The result of 4 will lead as 1, 6, 4, 9, and 2. Remember that the only the elements which exchange are only replaced, right? Other elements 6, 4, 9, they are not changed anywhere. Okay, so these were not changed, only 1 and 2 are interchanged with each other. So now this completes that the first element has matched with all others. The what this fourth step has ensured that this first element has been compared with all others, and the smallest element has jumped out at the first position. Okay, or I can say the first element has been bubble out at the first place. Okay, now what is this bubble out? Have you seen bubble forming in the water? What happens? Bubble can form at any depth of the water, but what happens? The bubble always tends to come to the top of the or surface of the water, right? So this sorting method is given name as bubble sort because in every iteration what happens, the smallest number or the number whose for whom we are doing the iteration, the place whom we are doing the iteration, at that place the right number appears. Okay, right number starts appearing. Okay, now this place was for the smallest number of this particular array. Okay, you can see that this is the smallest number in the your outcome, and you can see that after performing this iteration. Okay, now iteration 1, I will write it as iteration 1, and in this iteration I have done 4 comparisons. Okay, now in iteration 1 I will write it here also. In iteration 1 there are 4 comparisons to be made. Okay, and iteration 1 was for first position. Okay, first index, or I will write 0 index, and 0 index was compared with 0 to 1. Okay, now another comparison was 0 to 2, 0 to 3, and 0 to 4. These 4 comparison happened here. Okay, so this was iteration 1. Right, now see what happens in iteration 2. Okay, and after this iteration we ensure that the zero position, at the zero position, the correct number appears. Okay, and the correct number is 1, which appears at this particular position. Right, now the number comes of this particular position. Now I2, in I2. Okay, now in I2 we stand for one number position, one number index. Okay, now this index. Okay, now forget about this one. Okay, one I need not to, because one has reached to the correct position. Now what I need to do in iteration number 2, this 6 will be first compared. So I will again iteration 2, the first comparison will be between 6 and 4, right? And from this 6 and 4 you can simply see. Okay, I will I will write it as a comparison chart only. So I will simply write 6492. Okay, so 1641 I am leaving as it is, and the 6 and 4 is compared. So from the comparison, this is the first comparison that has take place. So this comparison gives the result as 14692. Why this interchange happened? Because 4 is less than 6, so it appears that the 4 should come before 6, so they must interchange with each other. Okay, now this 4 will be compared with this. Okay, so this is our second number position. 6 and 4 and 9. Okay, 4 and 9 when compared to each other, so they should not interchange with each other, right? Because 4 is less than 9, so there should be no interchange. Now I will also add one more comparison, that is the third comparison will take place. 4 is less than 2, right? 4 is less than 2. So what will happen here? So 4 is less than 2. It is false. So what will happen? 2 has to go to 4 place, right? So I will write this replacement here. It is 1, it is 1, 2, 6, 9, and 4. Okay, so this one is as it is, and 4 and 2 interchange their place. So this is the result of this third, and this completes your iteration number 2. Because after that iteration, the comparisons that will take place is 1 is compared with 2, 1 is compared with the third index, and 1 is compared with the fourth index, right? And so there were three comparisons, right? Three comparisons took place. And after this first location, after this complete iteration, what happened at first location, you get the 2 from here, right? And if I run other iterations also, so I3 will be like that only, that 1 and 2 are static now, where they have reached to their correct location. Now only 6, 9, 4 is left. 6 is compared to 9, no change. 6 is compared to 4, yes, there is a change. Okay, so we compare two comparisons. In I3, we are looking for the right place for 2, and there are the comparisons are 2, 3 and 2, 4. Two comparisons has been made. So there are two comparisons, right? So two comparisons have been made. So I3 and I2. Okay, I3, I2 and sorry, 2 is compared with 3 and 2 is compared with 4. So in this replacement, 1, 2, 4, 9, 6. Okay, this is the interchange that will happen in I3. Okay, now I will take I4. This should be the last iteration, because 1, 2, 4, 9, 6. This is the starting point, and we are looking for this particular position. So this will be compared with this. Now this requires an interchange. So what will happen? 1, 2, 4, 6, 9. This interchange will happen like this. So what I will write, I4 fourth iteration has only one comparison, because the comparison would be between 3 and fourth location. Okay, and after this third location, after this the second location, the second index was captured by 4, and the third index will be captured by 6. And obviously after that, uh, would there be any fifth iteration required? Because every time, now you can observe, in every iteration we are comparing, if iteration is for the right place of this particular, so we are comparing it with the all remaining locations, right? All remaining indexes, fine. So if you want to find out for this particular iteration, is this particular position, there is no element to compare after this. Okay, so we will not be running this particular iteration. Okay, this comparison for this particular number, this particular index will not be there. Okay, so now this is the problem solving mechanism that is followed by bubble sort. Okay, now what I will do, I will just explain you this program, and you will see how we have converted this logic into this particular logic into the program, right? So A5, it is 5 element array. This A5 is 5 element array, and we have also taken n equals to 5 if suppose you are required to change the number of active elements at a time. Okay, now see this carefully. We have used one for loop and another for loop, that is nesting of loops. Okay, now how you come according to the need of nesting. Okay, you can see that there are iterations being followed up, I1, I2, I3 and I4. These four iterations. Okay, so these four iterations were there. So the iterations are for four iterations, means first iteration was for this particular element place, this particular place. Second is for this particular place. Third is for this particular place, and fourth is for this particular place. You can see there was no I5. Okay, I5 is not required because every time there has to be a element after the particular element to compare. Okay, and if we take this I5 also, so there is no element after that to compare, so I5 will not be there. So the this is the I loop to this is the loop to make these I iterations. Okay, I1, I2, I3, I4. N is 5, so we want it to run from 0 to 4, right? N minus 1. Okay, and even 0 to 4, not 4, 0 to 3. Okay, the index is 4 and we want to run it to 3 only. Okay, 0, 1, 2, 3. Okay, this is the 0 index, this is the 1 index, this is 2 index, and this is 3 index. Okay, so these 4 we want to run for it. Okay, now you can see in every iteration why the nesting is required, that in this iteration you can see a number of comparison has been made. If you are going for this particular element, then it is compared with all the I plus 1 elements. Okay, I plus 1 and till the last element. Okay, so what we have done, we have started j with I plus 1, we have started j with I plus 1. So suppose I is 0 over here, so we will start with j to 1. Okay, so it will for this particular question, this particular element, it will compare with I plus 1. So it is I plus 1 is 6. Okay, and j is less than n. Where does it go? It goes till j is less than n. It means in the last of the index. Okay, so the 4 will be compared. So this will become j for I equals to 0. J will run as 1, 2, 3, and 4. Can you see over here for the 0 iteration, the comparisons were 0, 1, 0, 2, 0, 3, and 0, 4. Okay, so this is how the I and J goes. So this is the I and this is J. So for every I, the J is always J plus 1 to N. Okay, so J is I plus 1 to N. So I plus 1 and 1 to N. N is N minus 1, right? N minus 1, that is the last index. Okay, so I is always compared with I plus 1 to N minus 1, right? J की range हो रही. Okay, now what is to be done when to compare? Okay, now when comparing we just check whether AI is less than J. Remember, AI is always the target position. AI is always the target position and AJ is always the checking position. That is, this is AI. I will write over here, this is AI and this is AJ. Now, see this, that we always want that AI should be less than AJ. Okay, this is our target position. Where that all the target position should be always less than the checking position, right? So this is the target position and this is the checking position. But if it is greater than AJ, it means the target position is greater than the checking position. So what will happen? It means this is not an ascending order because the element coming previously is more than the element coming later, right? So this is if this condition is true, it means we require an interchange. Okay, we require a swap. Okay, so this is nothing but a logic for swap. A swap program we have already done. Okay, so swap, what swap means, you just swap what you have done here. Okay, this is what is swap, right? This I would say this three is simply sorry, I would say this two is nothing but a swap. Okay, you find that 4 is greater than 2. Yes, it is true. So what you do, you interchange 2 with 4, right? You interchange the place of 2 and 4. So it is swap, right? So this makes us to need of swap. So if anywhere you find AI is greater than AJ, so you need to swap then those. And the most important thing that you need to remember is to run this outer loop or iteration loop one less than the index. Okay, and this loop to be started from one higher than the one more than the I or the iteration number. Okay, and it should go to the last of the index. Okay, and it should not go to the last of the index. Okay, this thing you have to remember for bubble sort, and the logic why we need to do is you can is evident from this iteration 1, iteration 2, iteration 3, iteration 4. So this is the I, and for every I these comparisons I are I versus j comparisons. So for let us say value of I is 3. Okay, so value of I is 3, it means we are coming here. Okay, so at value of I is 3, now you can see that j will start from I plus 1, so j will start from 4. So you can see that j has started from 4 over here, and what is compared that AI is greater than AJ. You can see that AI is A3. A3 is compared with A4. So if it is greater than this, so you can also find over here that 9 was greater than 6. So 9 was greater than 6, then this condition was true. So this condition is true here. And if what happens when true, that the number interchanges, so this number is interchanged, and 6 takes the place of 9 and 9 takes the place of 6. Okay, so this is how sorting of arrays in the form of bubble sort is performed. Okay, two, and let it be 1 and 2, 3. Okay, now 3, 3, 4, 3, 4. Then I can take 7. Okay, then I can take 13, right? So this is the another sorted array. Now our objective is to convert it into an merged array M. Suppose I take it as M, so it should have the elements of these arrays as in the sorted order, right? So the output should be the what is the minimum number out of these two is that if I start scanning this first element and this is also first element, so I will start scanning them. So which is minimum, that is 1. Now I will move further this. I'm also giving you the logic, right? You can take an index I here and index j here, and you can start both of them as 0, right? Start both of them as 0, right? I is started as 0, j is started as 0, right? And for this particular thing, you start as ai. You can compare ai is less than aj. Okay, if ai is less than aj, okay, then what will happen? Less than, or you can also say equal to condition you can also take, because if both of the elements of the first index are same, that you have to choose any one of them, right? So you can take that if ai is less than aj, then what you can do, you can take k as index of this, okay, for the new element. So if this happens, so what you have to do, you just have to put this k as ai. Okay, and then what you have to do, what indexes you have covered, that you have covered that this particular index as you have covered, so you have to increase this I as I plus plus and k as k plus plus, right? You have to increase k so that it can be stored at the new position, and otherwise it has to be the other position. Otherwise you also have to write else will, what will be that the condition is ai is greater than aj. Okay, in the reverse condition, what will happen, in that particular location, the number to be coming as aj. Okay, and for this particular aj, what will happen, what will happen, this would be I plus plus, sorry, not I plus plus, here you have taken the element from uh, sorry, I will write it as a, and I will replace it as b, and this can be taken as a. So this would be b, bj. Okay, and you have to increment now j plus plus and k plus plus. Okay, so this is the logic that you can follow, right? And now let us see this how it happens, right? So b equals to 1, be the first element of this. Okay, so we will start from all 0, the k is 0, I is 0, and j is 0. Okay, so we will start from this particular condition. Now let us compare it first for the first time. A0 is less than, A0 is less than, I will write it as B0. Okay, so A0 is less than B0. This is condition in this particular. A0 is this number and B0 is this number. Okay, now this particular condition is false here. So what will happen? What will happen? This it will come here. Okay, so MK is this particular M0. So M0 will be BJ. Okay, BJ is B0. So M0 will be 1. Okay, now J will be incremented. Why J is incremented? Because you have accessed this element. Now you have to bring J to here. Okay, so J will become 1 over here, right? Now J plus plus. Now why K plus plus? Because you have used K as the 0 index. Now K has to move. The required index is K equals to 1. You are to look on the second number index. Okay, second index of the element, right? Then again you go for this comparison between these two will be compared. Initially these two were compared, now this was selected, now these two will get compared, right? Now 2 is less than 3. Okay, so this condition is true. So mk will be AI, and I will increment. So I will come here. I is initially here. Now I will come here. Okay. Now I will come here, and what will happen? This k will become as 2. Okay, I plus plus and k plus plus. Okay, now what will happen now? Now again it is compared that I is here and j is here. Okay, so these two will be getting compared. Now 3 is less than 6, so this will come as 3. Now k will increment as 3, and you have used the content of this, so this j will come here. Okay, now these two will get compared. Okay, now so it will come as 4, k will become 4, and k will become 4, and j come to here. Okay, now this 6 and 7 will be compared. So I will come over here, and this would be simply 6 coming here, right? And then this 9 and 7 will be compared, so 7 will come here. Then this 9 and 13 will get compared. Okay, 9 and 13 will get compared. So 9 and 13, this will come as 9. Okay, and then this 11 and 13 will come here. 11 and 13 will compare, so 11 will come here. Then this 12 and 13 will be compared. Okay, and this 12 and 13 will be compared, so 12 will come here and 13 will come here then last. Okay, so this is how k will increase more and more. Why k is required? Because the sorted array, the merged array, this is the merged array, and this is the output. Okay, and this is the logic for producing this output. So you can easily make a program. You have to take input first this array, this has to be in the sorted array, and if it is not in the sorted array, first you have to perform sorting of this. Second, you have to take this array, then you have to perform sorting for this. Okay, and then when you complete input of these two array and sorting of these array, so what are the steps? Input a, second sort A. Then third step is input B. Fourth step is sort B. And the fifth step is merge A and B. So this algorithm that I have given you is merge A and B. Right? So this is a program for your practice, and this is enough for right now, and we will do further programs of array in upcoming videos. Thank you.